In this video, we're asked to find the shaded area given. And when we look at the shape of the area, it's not a known shape. It's not a triangle or rectangle or square. It's more complicated than that. Now, one of the ideas to find the area of the shape is to decompose it as the combination of shapes that we know, like for example a triangle, a rectangle, semicircle, circle, and so on. Now let's start by putting all the information given to us onto the shapes. So here, for example, we are told that AE is parallel to CD. AE, this side here and this side are parallel, and then BC, this side here, and ED are also parallel, and we are also told that ED, this side, is perpendicular to AE. So we are going to put 90 degrees here. So 90 degrees here. Now we also draw a line from B to AE perpendicular to it, and this point we call it A dash. So we can say from the given information, the parallel lines, the 90 degrees, that A prime EDC is a rectangle. This is very important. So A dash EDC is a rectangle. What we can do, for example, to find this area here, what we can do is to find the area of the rectangle and then subtract the area of the semicircle. That will give me this area here. Now this is left here, the area of the triangle. This is quite easy to find. Good. Now we also draw a broken line from B to this side such that it makes 90 degrees here, and we know that this is equal to 4. It's given here. So this is 4 here. Now we need to find the length of this rectangle, which goes from here to here. Now we know this is 7. We need to find this. Let's call it H. Now here what we have a right triangle, so we can use Pythagoras theorem. This is the hypotenuse. One side is given, the other side is not given. So the Pythagoras theorem tells me that the hypotenuse square is equal to the sum of the square of the two other sides. That will give me H squared is equal to 25 minus 16. That gives me 9. And then H is equal to the square root of 9. And that gives me 3. Now the units are millimeters. Now we found that H is equal to 3, and therefore all these sides is 3 plus 7. That gives me a 10 here. Good. Now we have all the information now to find the area of this part here without the semicircle. We just take the area of the big rectangle, A dash ECD, which is 10 multiplied by 4. So let's call this area area 1. So it will be the area of the big rectangle, 10 multiplied by 4, and then we subtract the area of the semicircle. So the area of the semicircle is half, semicircle half, and then pi, and then r square. What is r here? The diameter is, so diameter small d is equal to 4, therefore the radius is equal to 2. So pi r square, 2 square. Now remember the formula of the area of a circle is pi r square, and then semicircle it's half. This is what we have done here. So we know the area of this side here, this part. Good. What is left is the area of the triangle here. Now we know this side. We know this side is equal to H. So we put 3 here. Now this side here is going to be, this is all 7.5, it's given. And this is 4 here. So this is going to be 7.5 So let's put it here. 7.5 minus 4, that gives me 3.5. So this is 3.5. Now let's call this area A2. So A2, the area of the triangle, it's a right triangle, it's 1/2. This is a right triangle here, because this is 90 degrees already. So it's going to be 1/2 the height multiplied by the base. The height is 3, the base 3.5. So 1/2 3 multiplied by 3.5. Now the area, the total area of the shaded region is equal to A1 plus A2. A1, it's equal to 40, 10 times this. And then here we keep pi for now. This is 4/2 minus 2 pi. Now this is, let's keep it as 0.5, which is 1/2, 3 by 3.5, and then we now can go to the calculator and do this. So using a calculator to calculate this and round it to the nearest unit, the result is 39 millimeter squared. Now what do we retain from this problem is that when the shape is complicated, decompose it into known shapes and then either add or subtract the areas.